And there we go. Hello everyone. So today, as I already mentioned a bit earlier, we're going to do like a quick walkthrough of getting Orx, building it, and starting a new project. And then we're going to discuss a bit the different options we have. So to do that, I will just start from like a Linux virtual machine that has just like GCC installed and the library we need to build Orx, but Orx hasn't been synced on it yet. So here we go. Whoop, and of course, why is my computer lagging now? That's not a good sign.
And I guess, Alan, you're sharing video somehow? I don't quite see it.
You should be able to see my video on the... Okay, so my computer froze. I don't know if you can hear me.
Yeah, we can hear you still.
Okay, because I
Yeah,
cannot
I can
move
hear
my
you.
mouse, and let me try to restart my mouse actually. Maybe it's just my mouse that broke. Yeah, that was my mouse.
Even if it's... Oh, okay. If everyone else is frozen, can everyone else still see the video?
Yeah, you should be able to see the video if you click on the live voice channel thing.
Okay. Alright, well, I'll click around and see what happens.
Yeah, I can wait until you actually find the button to see it.
Oh, no, it's alright. Go ahead, that's fine. I'll catch up.
Okay. So we are just going to, back on track. So we are just going to clone Orx using Git. That shouldn't be taking too much time, 80 megabytes, and the clone is done. Then we're going to go inside the Orx folder, and we're going to run the setup script. And same, setup shouldn't be too long. We already downloaded the dependencies, and they've been extracted, and all the projects have been already created. So we're almost done with our setup for Orx, and there are two important messages I want to highlight because those are questions that came back a few times when setting up Orx on Linux, especially with Codelite. So the first one is like you have to make sure that you have two dependencies installed on your system. Basically, it's the OpenGL dev library and the Xrender one. And lastly, there's a message that until recently it was not colored, now it's green. It says that there's a new environment that has been detected, and it asks you to log out and log in to refresh your environment if you're using an IDE. Otherwise, if you start Codelite right now, it's not going to pick up your new environment variable. And actually, it's something that we're going to demonstrate right now. So let's actually start Codelite. There we go. Development, Codelite. So the workspace has been generated, and I should be able to find it in Orx, code, build, Linux, Codelite, and it's Orx workspace. So building Orx itself will work because Orx does not rely on the environment variable, but creating a new project, you'll see that it's going to not work if we don't log out and log in. So we're going to build Orx. It shouldn't be too long, though it's a, keep in mind it's a virtual machine with like I think I put like 2 CPU cores and not much RAM, so it definitely takes longer than most things. So it's done. So now Orx has been built. So if I go here in CodeBean, I should be able to start a debug version of Orx, and there it is. Now, if I go back here, we're going to create a new project, and usually you do that with the init command. And right now, we're just going to create my game, and we're not going to add any extensions or anything, just to try to see if we can build it. So, project has been created, and now if I go back to Codelite, I should be able to open that workspace that has been created as well. As you can see in the log, actually, once you create a project, depending on the platform, it's going to create different project files and solutions. So on Linux, it's going to create a Makefile, project for Codelite, and project for Codeblocks. So here now, if we open this, which is now in my game, build Linux, Codelite, my game, And if I open this, if I try to build it now, you can see that it's going to complain. It says the following environment variables are used in the project but are not defined. Orx, built anyway. So no, I don't want to build. Then that's the message we saw earlier in green. In order to be able to build, I need to first log out. So I'm going to log out and log back in. And by doing so, now Codelite will pick up the new environment variables. So if I actually start Codelite now, it's still going to be on the same workspace, which is the my game one. And now I should be able to build my game with no problem. And here, if I go to my game bin, we can see that my game has been compiled. So the debug version with the symbol is about 88 kilobytes, and I should be able to run it. You can hear sound, and you can see the logo that sounds. So that's the thing about Codelite. So now I'm not going to use Codelite because I'm not a big Codelite user. I will just keep with the command line. But we're going to try to see what we can do with to start a new project. So if we go to Orx and we call init, and instead of typing name of the project, we type help, it will give this to us. So basically, we can see that the usage is init with the name of the project, and there's a bunch of extensions that we can activate or deactivate. And they're listed below, and I'm just going to go over them to explain what they do exactly. So the name of the project is required, and that's basically where the project is going to be created. If the project was already created, it's going to be overwritten, and there's going to be a message warning you about that. The archive extension is basically the support to put all your resources into a zip file. So like one or multiple zip files, you don't have to stick with just one. So basically, instead of having all your like textures and sound and config like in everywhere in on your file system, you can put them all inside the zip files and reference them through Orx, and Orx will be able to load them. It's important to note that all those extensions, none of them actually modify Orx itself. They are extensions. They extend Orx itself. So the archive works by registering a new transport for resources, and it just tells it how to handle like a zip file and how to find things inside a zip file. Because by default, resources by Orx from resources that with Orx without any extension can be found on the file system or in APK files on Android, and those are the only resource transport that shipped with Orx without any extension. C++ is just going to create a C++ project instead of a C1, and this extension is active by default, and you can see it actually here. And it's the only one that's active by default. All the other ones are not active. imgui is to activate the dear imgui support, which is usually used for doing like tooling and debugging UI. And you can see that this one actually requires C++. So if we were to try to create our game, let's do the same thing. And I'm going to ask, I don't want C++, but I do want imgui. And there's a conflict here. So when you start that, you can see that imgui triggers C++, and here it asks about because the following extensions have been both required and prohibited, C++, because we say we don't want C++, but imgui says I need C++, so you have to figure out what you want. The other extension, the mod one, is the mod audio format going back to the 80s and 90s from the Amiga scene. It's a protracker format, so you can actually use like old school music that are very tiny in space and give you like a very retro feeling. The movie extension is an extension that can read like MPEG-1 movie with MP2 audio. It was both a proof of concept to see how you can integrate other like movie decoding libraries like I don't know, like Bing, for example. And if your needs are just for like a splash screen or something like this, you can just stick with MPEG-1. The files are going to be a bit larger, but you will see that when I'm going to create one with the Orx logo, which is like a few seconds long, the file itself is about 3 megabytes, so it's probably not what's going to take the most place in your game anyway. Nuclear is another immediate GUI extension, so it's a bit like DRM GUI, but it has different features. Probably less featureful, but it's themable, so you can actually slap your own theme on top of it, and you can make like in-game menu more easily than with DRM GUI, which is really geared toward debugging and tooling. The remote extension is to be able to load resources remotely. So like we added resources coming from a zip file with an archive extension, here we can actually fetch extensions through HTTP protocol. It's mostly like a proof of concept, but it's also useful if you want to work with a remote team and being able to modify assets on the fly and having it hot reloaded by someone executing the game remotely. So I did some tests like a couple of years ago with Nico, and he was like in Poland, and I was in North America. And even with the lag, we were able to have it working with maybe like a split second before all the assets were reloaded. And as for proof of concept, it works quite well, and it could even be used like for small teams if they want to do like a hot reloading across teams. The last one is scroll. It's a C++ convenience layer that comes with a config binding to C++ object. And this one is the one I'm using in all my own project. It also comes with a level editor, but the level editor hasn't been maintained actively. Keep in mind that scroll is now like something like 12 or 13 years old. Scroll is still maintained, but the level editor needs to be freshened up. And I plan to actually rewrite most of scroll because a lot of features that were added at the scroll level now made it also inside Orx itself, and there's a bit of like a duplication there. So I want to spend some time cleaning this part. But let's say that we want scroll for our game. We also want being able to play mod audios, and we want being able to play movies. So you just add the list of extensions you want. You start your project. The project has been created. So now if we go to my game, and we can go to build, we're going to build it on command line this time. So building the game, done. And if we go back, if we go back to the bin and look at what we have, we see that my game now is 453 kilobytes in debug with all the symbols. And if I run it in debug, you see that there's our movie playing at the beginning with audio, and then we have music playing, which is coming from the mod. The mod itself, so for people who are not old enough, like this kind of format allows you to have like a very specific kind of vibe for like very retro wave, but the file size is like tiny. Like this mod is about 150 kilobytes, and it lasts for like a few minutes. And we can actually see that everything is in memory here. We can see our scene. We can see we have an object called music, an object that is called object, not very inventive, and has an effect which does color cycling, and it's using a texture called logo. And there we are. We have we can actually go to our source folder, and we can look at our source file, and we can see that we have like basic skeleton for starting a new project with like registering an update function. Because here we're using scroll, we're actually binding the class object to the config object. And here we go. We have our project that's been created, and we can start from there and add whatever we want. And that will be it for the presentation of init and the extension. So unless there are like specific questions regarding init itself, I'm just going to turn off the VM, and we'll use my native machine for any demonstration in the future to get better performance. So as I don't hear anything, assuming that I can close everything. There we go. So, are there any questions regarding Orx, no matter the topic, that people would like to ask? If so, I'm happy to answer them. Otherwise, I will just use with whatever I have at hand.
If you're too shy about getting on the microphone, go ahead and drop your question into the text chat. and it'll be read out for you.
Yeah, definitely. And also, if you were trying to ask questions, I just want to remind everyone that you are muted, just in case. Well, hey. I can barely hear you, so let me actually bump your volume a bit.
Can you hear me now?
Yeah. How are you doing?
I'm fine, thanks. Yeah, okay, so for any new game project, would you always recommend having this scroll library?
Personally, yes, but it depends on what you want to do with it. If you're going to have like a very simple game jam or like doing a small prototype, it's probably not useful. If you're going to have like entities with dedicated behaviors and things like this, and you're going to have like different variations of these entities, I would definitely recommend using scroll. It's really a thin layer. There is nothing precompiled. It's all inline functions, and all it does is being able to like bind classes that derive from a class called scroll object to a config section, and it also supports inheritance in config. And it wraps a lot of community functions, like being able to set, I don't know, position, speed, animations, as well as wrapping some events, like all the collision events, the shader events, they're all wrapped as virtual methods. And so it's much easier to integrate than having to register an event listener and check who's sending the event and this kind of thing. All this has been abstracted to you for you, and so all the boiler code plate has been done for you. So it's really a convenience layer. It's not groundbreaking, but it's useful. So I would definitely recommend it.
Okay, thank you.
Actually, if you want, I have like a small project I'm working at the moment for another video, and I'm using it so I can showcase how it works. Basically, recently I realized that through Humble Bundle I bought some asset packs, and some of them were like a lot of variations on weapons and character facing 8 directions and things like this. So I thought, hey, that could be interesting to see how we can layer stuff in Orx and being able to simply do like character customization in 2D, as well as trying to automate config generation so that we don't do it by hand. So that's the goal of this project. And if you want, I can give you like a quick walkthrough. So if we're looking here, it's on the right pane. The left pane is basically Orx usually, and the right pane is my character. So before we go through the codes, I'm just going to show you what it does. And for that, I'm going to go here, workspace, and it's called Mixnmatch. So if I start Mixnmatch, there you go. You should see 2 characters, and they are actually players that are moved independently. I map them on different keys and also on joysticks, but I don't have any gamepad connected at the moment. But they would be controlled with different gamepad. They can walk in all 8 directions, and they have a lot of different attachments. They can also run. And if I reload it, you can see that all the attachments and all the clothing is actually random and loaded on the fly. So there's a female character on the left and a male character on the right, and all their weapon and garments are selected on the fly at the moment. But we can actually drive this selection. Like for example, I want to create an NPC, and I'm going to do it on the fly in the console. But of course, if you were to do it in your game, you would probably do it in config, or at least in code to generate the config. But let's say I want a character named NPC, and I want it to be a male character. So what I'm going to do is I'm going to say I want the parent of my NPC section to be a male character. And now if I were to create NPC, it will be a generated, randomly created male character. But I want to be a bit more specific. Let's say that this NPC is not going to wear any pants. So bottom, I'm telling it you don't have any bottom. And also I want, like for example, to make sure that he has a bright, like a laser sword and a kite shield. So I'm going to say set NPC your weapon is going to be the male weapon, bright sword and kite shield. And now if I were to create that guy, it's going to be created with those constraints. So the rest will be randomized, but those constraints will be respected. So as you can see, he has no pants and he has a bright sword. You don't see the kite shield because in the idle animation it doesn't show, but we can control it. I did not assign any keys, so I cannot move it like this. I did not assign it to like any joystick either. But what we can do is actually we can trigger the input programmatically. So all the characters that would be created right now have their own set of virtual inputs. And to do that, we are going to get, so we're going to store the current inputs. Oops, I need to that current set. We're going to select each set of input, which has the same name as the section we used. And we're going to ask him to move right and do it indefinitely, and then we're going to go back to our previously selected set. And I probably messed up some things because it's not moving, so let's see. Get current set, select set NPC, input set value. Oh, yeah, of course. I didn't give the value. There we go. So now is going away with his bright sword and his kite shield. So all the characters I create like this have their own virtual set of inputs. They can be bound to like physical inputs, like we did for these little guys, or they can be like used programmatically from command or from code. And all this actually is very, very little code, and that's what we're going to show here. That this is the entire character class. That's what manages all the inputs for those characters. And you see that there's not much code. Basically, we have that character class here. And if we look at the main game code, which is not much compared to the init one, the only change I made is that I'm going to generate data programmatically from that generate data function. And you can see that I'm going to generate characters and animes. And we're going to go over that a bit later because that's really the goal of this test. The other change I made is that if a reset input has been triggered, I'm creating an object called reset, and that's the thing that actually kills all the other objects and recreates the scene, and so the new players. That's all the change we've done here. And we can see here that we have a character class that's bind to the character section. So any section that inherits from character is going to be associated with an instance of the character class. So that means that the NPC was inheriting from the male character, which was inherited from the character. So by creating an NPC, an actual instance of the character class was created for it and was bound automatically to it. And no matter how we create the object, if we create it through scroll, if we create it through like a spawner, if we create it in the console as you've seen, this binding will always happen, no matter what. So that will give you the how can I say that? The guarantee that no matter how you're going to create that object, if it has been bound to scroll class, the binding is going to be honored, and you're going to have your code run on it. So when the object has been created, we actually enable his input set, and basically we use the same name as the section right now. And we say that we want the orientation to be down. And if I were not doing this, I think the spreadsheet, the default orientation is right. I just wanted them to start down, so I put it in variable here. I have nothing on delete, and the update for the entire movement, which handles like the idle, the move, and the run, is here. And what I do is basically I'm getting the current set. I'm storing it for later so I can restore it when I'm done. I'm going inside that object config section. So for the NPC, it was the NPC section. And I'm going to start assuming that they are idle. And then I will look for the move right, move left, move down, and move up inputs. And I will create a vector based on this. So it's going to be a normalized vector. And if you're using like analog sticks, it's going to be like, you can actually like move it slowly and not just like full speed or regular speed. If this is null, we skip this entire part of code and we just stay don't move. And then we play the animation. The animation has been selected here as idle, and we also retrieve the current orientation. And that's going to define which idle animation we want to play, like idle right, idle top left, and whatever. We set the animation, and that's it. And for moving, what I do is that I'm looking if the run action, if the run input has been activated. I bound it on Shift on the keyboard and on the trigger on the pad. If it's going to be activated, I'm going to use the run speed and animation, otherwise I'm going to do the work one. I'm going to go from the Cartesian to the spherical space. In the spherical space, I'm going to retrieve the speed and set it as the raw component. So basically, it's how fast I'm going to move. And I'm going to find the orientation based on the theta angle, which is the horizontal angle. And I'm going to chunk it into 8 different sectors by simply dividing the angle by pi by 4. And this here is just to handle like the wraparound on negative values as well. And with this, I get my my orientation, which is one of the like right, bottom right, bottom, down, down left, left, and so on and so forth. And then I transform that vector back into Cartesian, and I apply it as move. And so this entire code allows me to run any of the characters and in all the direction, running and idling and remain like play the idle in the last direction they were facing. And if we look at, is there any questions before I continue on this? Otherwise, I will go back to the, oops, yeah. I'm going to go back to the config itself. So the config itself, here is, so I created 2 versions, one that is entirely handmade, and you're going to see it's very long, and you don't want to do that because it's not sustainable. And the point of the video is to show that you can actually generate stuff on the fly at loading time, and that it actually doesn't take any more time. Like when I start it like this, even though it's using the generative approach, it's as fast as if I were using the handmade one. You don't see a difference. It's basically the same thing. So now I'm going to look at the handmade config. And both the handmade and the generative one use the same basics. So like the display settings are exactly the same, the main objects are exactly the same, like the scene has player 1, player 2. Player 1 is a female character that is mapped to the input WASD, and the gamepad 1. The player 2 is a male character that's mapped to my arrow keys, and the gamepad 2. And my characters have been scaled twice so that we can see them on screen. That's a list of orientation that they can actually use. And the child list is that basically every single layer we add on top of each other. So like there's a base character, which is like a naked character. Then they have like a bottom part, like trousers and bottom garments. The top one, they can have hair, they can have weapon, they can have a head, and they can even have facial hair, which is only used for male characters. But it doesn't matter because the female character will not find any version, so it will not create objects for this. So here I'm just using a command to take them based on a list. That's why I was able to like force things and get randomized version otherwise. Here, by default, it's going to take a random of all the variations that exist in file, and if it's forced, it's going to use the forced value. So all this is common to the generative one as well, and here are the layers to see that I want the bottom to be slightly on top of the base one and the top slightly on top. So basically, it's a priority of rendering. And here I did actually a custom combination of like multiple weapons. So like we saw earlier that I used a male weapon, bright sword, and kite shield. So this object is basically just like a wrapper to create two children. Sorry. One is the kite shield and one is the bright sword. And this way, if I don't have to create them separately, I can just create them as like a set by using this. So these are just sets I made because they make sense for like 20 weapons, not 20 weapons, like dual wielding weapon. And here we go to the characters. We can see that the female characters has all the variations for the base, and there are 8 of them. And you can see that the same for bottom and top and hair. And weapons are even like different variations. So like it's based on the weapon name and not on their class. So there's a bunch of them as well, and you have to write all this by hand and make sure you don't make a mistake and a typo or anything. And that's definitely not the best way to go. Same thing for the male character. It's even worse. He has even more weapons than the female. So this already is like, that's a good reason already not to do that and try to find a way to automate it. But it gets worse because for every single of these items, I need to tell them where the sprite sheet is with the animation in them. And if we look at those, so I'm going to open one actually. Let's open the male witch hunter head, and you will see that those textures are huge in these data sets, and they are like 3840 times 4000 in 32 bits, so basically it's 60 megabytes in memory for each texture. And we have something like 105 variations, so if I were to load everything in memory, it's going to be 6.5 gigs of texture just for this. And here you can see, well, like the hat is probably not the best one. Let me try to find a better one. So let's take, I'm going to take base. I'm going to take like the base female archer. Okay. So here we can see better that we have all the variations for all the animations. I'm only using 3 animations for the purpose of this video, but it's because you will see that just for 3 animation in all directions, there's a lot of manual typing, and that's, I didn't want to go further than that for demonstration. So basically, there's the walk first, there's all 8 walk, then there's all 8 run, then there's only all 8 idle, but only 3 frames for each idle, whereas there are 8 frames for the walk and the run, and you can see that there's a lot of variation on this. And on top of this, you have to add like the same animation for the top, same animation for the trouser, and so on and so forth. And it's a lot of things to handle if we were to do it manually. And here you have to define all those variations here by hand. And you can see on this sidebar that there's a lot to type, and there's a lot of way to actually make like a lot of typos, because that's a lot of content for this object. On top of this object, we have to define the animations. We have to define the walk animation in all that direction, the run animation in all direction, the idle animation in all direction, the link between the animation, and the frame for each animation as well. And that's a lot of manual content. You can see that we have 620 lines just for handling 3 animation with all the character variations. And all this part here until here, this part here, we can actually use a programmatic approach and generate it on the fly. The part above is actually things that we're going to keep, like the different players and things like this. And now if we're going to look at the gen version, you can see that the beginning of the file is exactly the same. Actually, you know what? There we go. We're going to put them side by side. You can see that it's exactly the same until we reach the part here that says automated, and here the part that says handcrafted. And here we're here. So we have all this, which is manual typing, which I've done once and I really didn't want to have to do. And here that's a generative, automated generative one. And you see that it's quite short compared to this. Basically, I'm telling the characters, all the variations of the characters, and for all the variation of character, all the layers I want to have. Like for example, I have facial hair for the male, but I don't have it for the female. And for all the different layers, I'm giving them the variation of the layers. So like the classes for everything except the weapon. The weapons are specific names. And this is basically, with the code I'm going to show you after, this plus a bit of code is going to create the equivalent of this until here. And that's quite a difference, especially if you add more variation than that. Here, adding like a third class, like a child class, it would be just like 1 line here and like 5 or 6 lines for all the variations. Whereas here I would have like dozens and dozens lines to type. And it gets even more annoying with animations. Here the animation, this part is handcrafted, so you will actually like find it here, or the equivalent. But the generative part is basically this. It just, I'm saying that this animation site is going to be considered for generative, for procedural generation. and I want all this orientation. And these are the list of orientation that we found in the order in the texture. So like the down, left, right, up, down, left, up, down, right, up, right. That's the order they are defined in the texture. And here are the order of the animations in the texture as well. We first have walk, then we have run, when we have idle, and we define how many frames for each of the animation. And there are actually 6 idle, one after each other. So if I wanted to add like a second idle, like alt idle, all I have to do is do this, alt idle equals 3, and now I do have my alternative idle animation, and it was like 2 lines modified. Whereas here, if I wanted to add it, I would first have to come here, add all 8 variations of the alt idle, add all the links here, all the links for the alt idle to go back to my regular idle, and then for each one, I would have to tell them what are the frames and the duration and things like this. So this is definitely more scalable than doing it by hand, and it's also much less error prone. So if we go back to looking at the code itself that we saw earlier, at the beginning of the init here, I have a function called generate data. And the generate data is going to call 2 things. One to generate the characters and one to generate the ending. And you see that there's a bit of code, but not that much. Basically, for the generate characters, it's going to transform this part here into like the very long one that we saw, that all this like here up until this. And what it's going to do is basically go through all the characters. For the variation of characters, it's going to take all the different defined entries. For each different entry, it's going to take all the different variations inside them. And after that, it's going to retrieve the texture format, and that's how they've been organized in the data folder. And it's going to output basically the name, the composed name, inheriting from the right layer with the right texture on top of it. And that's what this little code does. For the animation, it's something very similar. We're going to look at all the different configs that have been loaded in memory. We're going to look if one has a generate set to true inside them. If yes, we're going to look at the list of animation, which are here. We have walk, run, idle. And for all the animation, we're going to combine them with all the orientations that are defined here. And we're going to basically create all the variations like you've seen. And we're going to push that all in config. So basically, when this executes, even though we are using Mixnmatch, even though we're using the gen 1 here, if I were to run the binary here, and if I were to look, okay, I want to get the texture of the male base archer. I think that was it, and I want the texture. See, and it tells you that it was male-based archer sprite 1 WebP. We did not write it manually. It was generated on the flight at loading by Orx, and I timed it on my machine. It was about 10 to 11 milliseconds. So within the frame, everything was generated on the fly. So that's one way to automate your data generation. Not everything has to be laid out in INI. And actually, I encourage that everything that is repetitive and that can be refactored, like into like patterns, definitely do it programmatically. It's going to be more safe. You won't have like issue with typos or like copy-paste errors and things like this. And it's also much more malleable, and you can scale more easily. Like for example, here you can see that the guy, let's say the guy has a top, but if I were to remove here and I say, no, male actually, they do not have a top, and I'm not generating top for them. So now if I'm going to start it, no matter what I do, the male cannot have a top because those config sections have not been generated, so they cannot be found, and my male is always going to be topless. So that's the thing. And that's, yeah, I want to turn that into a sample video at some point, but you get a glimpse of the idea behind it.
Quick question on the generation.
Yeah.
Are you just generating that to memory, or are you going to write that out to a file and Orx reload it?
right now I'm generating to memory. If the process was very long, let's say it takes like 30 seconds or like a minute, I would do it offline and generate the data in config and then use that config later on. But as I said, in this particular case, it takes 10 milliseconds, so I don't see the point of doing it offline and adding an extra step of cooking my data for the game itself. I'm just generate it on the fly in memory. Both approaches are correct. It just my choice is that if the processing part when you load your game is negligible, like in order of tens or hundreds of milliseconds or even a few seconds, I don't see the point of doing it offline. Does it answer your question?
Yeah, no, that's great. Thank you.
Any other questions on this or on anything really? I went down this path because there were not many questions, so I could like showcase any kind of things. Yesterday when I was trying for ideas, I remember I was working on that, but I also was playing like with clock and showing that even though the mod is not, the decoding of a mod is not part of Orx itself, it actually uses hooks that are part of Orx and that makes it be, behave like any object. Basically, I can attach a clock, change the pitch, change the volume, add filters. Oh yeah, it's something that I have not shown since last November or December. Orx now supports filters, and filters can be added on the fly. They can be, modified on the fly, and they can be added either on object or on sound buses directly. So like if you want to modify like all your sound effects because you're underwater right now, you don't have to apply the underwater filter on all your playing effects. You just put it on the bus of the sound effects and they will all just change like this. And similar like for music, if you, I don't know, like you're in a cave, you just take the bus where the music is playing and no matter what is playing on that bus is going to have the effect as well. And those filters can be added on the fly, they can be removed on the fly and modified on the fly as well. Everything of course is config driven, so you can change that the way you want. The only part that is not config driven, if you want to do the processing of the filter yourself, like retrieve the actual packets, like the buffers of the sound, modify them yourself with your own algorithm, and send them back to Orx, well, obviously you have to write some code there because you need to get the packet, modify them. But if you're using some of the predefined filters, and there's quite a few actually, if we look at creation templates, now there's a filter section. Those are all the filters that comes with Orx itself. Thanks to miniaudio, because that's where they're implemented. We can have like delay and echo. We can have peaking, notch filter, high shell filter, low shell filter, band pass, high pass, low pass, and even our own bi-quad filter where we specify all the separate parameters like you would do in advanced mixing environments. And you can also control like you can have more than one listener. Before that, Orx only had one audio listener with OpenAL. Now you can have up to 8 or something like this, if I'm not mistaken. That's actually in the settings template. And no, four listeners at the moment. So basically, like you can have like a split screen game, and everyone have their own like proximity to the sound, and it's going to mix correctly. And all this happens, of course, on separate thread and will not impact your frame. And it applies on stream as well as samples that are loaded in memory. So this seems to be working quite well. miniaudio is really a great library. It takes a bit to get used to its API because there's so many things in it. But once you get into it, it's quite easy to understand and even to modify. Like I had a few bug fixes that went back up in the main miniaudio repository, and it was quite easy to submit those fixes. And the guy who developed them is very nice and very open, and it's great to work with. So I'm quite happy with this. So we do not rely on libsnd file anymore, and we do not rely on OpenAL anymore. We are using miniaudio on all the platforms, including Android and and iOS. That also means that all the audio capabilities are similar on all the platforms. So like we can decode MP3 on all platforms now, we can decode OGG, Org Vorbis on all platforms as well. And we can record audio on all platforms. We can have filters on all platforms as well. Another thing that's quite nice is that now if you change your default output, by default Orx is going to go to your new default audio. You don't have to like stop and restart like before, because miniaudio handles that for us. It handles the OS event to find the current default audio and switch on the fly to it. So there's a lot there to demonstrate. I definitely not ready, but if you want, I can like show some sound. But I don't know how well it goes across streaming like this, especially if I add things like echo and something like this. It might be a bit too much for the audience ears. But know that it's here. And my point for the mod is that let's create a new project. So I'm going to init my game again, and just going to ask for mod, and up. It's going to generate all the Visual Studio because we're on Windows, in addition to make Codelite and Codeblocks. So I'm going to actually open my game SLN with Visual Studio because that's what I'm using on Windows. And there it is. And here I can build the solution. It's going to be almost instant. There it's done. And we're going to do the release as well. And if I run it, of course you won't see it because I'm on the second screen here. So what I have to do is go to my game INI and say that I want it to start on the second monitor, even if it's like a fake full screen. So here you hear the audio. So there's an object called music. We can see it if we look at all the structures that are in memory. There's one called music, and you can find it. And of course we can like pause it, and we don't have audio anymore. So even though this is decoding a mod, so like the Amiga mod on the fly and then feeding a stream on the fly, Orx doesn't know about this. So basically it's using the event that have been set by Orx to modify stream on the fly. And if we look a bit more in config, if we go back to my game and look at the config, we can see that the music object here it has a property called mod with the actual mod here and the volume. But there's nothing about like a sound list or a sound or things like this. It's because the extension, the mod extension, is going to check when an object is created if they have this key defined. If this key is defined, it's going to hook itself to like the audio hooks for this object, and it's going to modify its config on the fly. It's going to add a sound list, and it's going to add an empty string with 2 channels at the current mixing rate of your device card. I think mine is like 48 kilohertz. So now if I look at the get music, and if I'm looking at the sound list, you'll see that there's actually a value. Even though there was nothing defined here, it's been added by the mod extension. And you can see that it's using itself as a sound list. So basically now we should be able to find the music property inside the music object. The naming is probably not the best, but you can see that it's like we were creating an empty stream with 2 channels and 48,000 hertz sample rate. And this empty stream has been created by Orx, and the mod code, the mod extension, is hooking itself on the event for this channel, and it's going to fill the packet on the fly when they are requested. So on a separate thread, every time an empty packet, it says, okay, I need that many samples, please fill them. The mod code is going to run its update loop. It's going to decode the mod itself, generate the samples, and send them to Orx, and that's how we can actually hear the music. So like, for example, if I unpause the music, it's now back, and it behaves like any sound. So I can add filter, I can change the pitch, like the pitch of the music. I want it to be like slower, and you can see that now it acts like it's slower as well. And so basically, everything that's supported by Orx in terms of audio feature is going to be adapted to the mod and as well to the movies as well. So like if you have a movie, you can change the pitch of the movie, you can play it slower, faster, based on clocks and things like this. It's all because it's using the same pipeline inside Orx, and it's just extension on top of it. I'm going to stop the music now so that I'm not killing your ears. And if we go to like my game, oops. Was here, my game, data, I think there's a music, and if we're going to look at that, we see that the Stardust mod is only 150 kilobytes, and which is great for this kind of music, and especially if you want to make like retro wave and old school stuff. And I think
Can we?
yeah.
Sorry, can we layer filters? Can we have an echo and a faster effect? Switch them in and out, and it doesn't restart or anything like that. Yep.
Let's do it on the fly. I'm not even. Oh, actually, you know what? We're going, instead of doing it in console, we're going to say echo. So that's a type is delay, and this we can actually look here. Remember, we have the cheating, the cheat sheets, like in the creation settings. We can look at the filter, and we have the delay filter. Type basically is delay. So what we do is, doesn't matter the uppercase, but we're going to do it like this. Type is delay. We don't want to use custom param, because use custom param means that it's going to, like for shaders, it's going to send events every frame to see if you want to change the amount of delay and the amount of decay. If we don't set that, the delay and decay is going to be fixed, and there's no event that's going to be sent. It's basically an optimization. If you wanted to change that on the fly, you set use custom param to true, and then you get events every frame, and you can change the parameters on the fly if you want. But it's also more costly because there's an event that's been sent. Here, for example, we're going to have like a delay of, I don't know, 0.8 and a decay of 0.5. So basically, for every echo, we're going to have 0.5 of what was before. And this is a filter. We define our echo filter. So now if we're running it, and we have our object, our music object, so which is this one, we can add a filter. So adding a filter, and that filter called echo. And now you should have an echo. It's probably not the most pleasing experience, but you should hear the echo on that music. And same thing, we can actually remove all the echo, and we're back to what it was. And same for the like accelerating and things like this. And knowing that clocks can be set on a hierarchy of objects. Like for example, right now we have, if we look at all the object structure, we can see that we have a first object called scene, which has two children, one called music and one called object. The one called object is the logo, the spinning logo in the middle of the screen. And the music one is the one playing the mod at the moment. If we were to set a clock recursively on the scene, it's going to affect everything. So let's try this. We're going to create a clock named CL, and we're going to ask it having a modifier list of multiply, and we want it twice as slow. So now we have a clock we can apply onto our scene. So what we do is object set clock. Oh, first we have to find the scene. Sorry. So we're going to find the scene. That's a grid of the scene, and you can actually check that the scene here is 000F, and you see it's the same one here. Now we're going to set the clock on this object, and we want CL, and we want it recursive. And you see that everything has slowed down twice as slow, including the angular velocity on the object, the color cycling, and the pitch. But now it's a clock. The clock is applied on it. We can change the parameter of the clock on the fly without touching the object. So if I say I want to change the modifier of the clock, I want to see now multiply, but slightly faster. It's going to go a bit faster, oh, and then a bit faster, and then a bit faster. Oops, my bad. It's because I forgot to type CL. Let's try this again. Yeah, a bit faster, and back to the regular speed, and we can actually even go like much faster. And you can see that like Orx logo is spinning faster, the color cycling is faster, and of course the music is just like going into chipmunk territory. And so yeah, so you can change all the time stretching for like hierarchies of object, and it's going to affect everything like always. So like their physical properties, their visual properties, the shaders, the effects, the spawners, the pitch for the audio, and let's go back to regular speed. So does it answer your question?
Yeah, absolutely. That's cool. Thank you.
My pleasure. And of course, you can change the parameters of the filters as well if you wanted. Like for example, if you wanted first your decay to be very slow and build up upon time, you use the use custom param. You would receive an event, and this event you can say now my decay is 0.1, now my decay is 0.2, now my decay is 0.3, and so on and so forth. And your decay is going to build up and change over time on the same filter. And we can do the same with buses. So instead of like doing it on a per sound, we can do it on a group of sound at the mixing level. So it's not going to be more expensive. It's actually going to be less expensive than doing it per sound, because all the sounds are mixed physically inside the bus, and then we apply the filters on top of the bus itself. So instead of doing n filter calculation, like if you have like n sound playing, we're going to do one filter calculation, but on the pre-mixed sounds that come in. And of course, you can have as many buses as you want. So you can have like a bus for like voice, a bus for sound effects, a bus for background music, a bus for whatever you want. And you can move the sound into separate buses at runtime, and the buses are also hierarchical. So you can have like buses inherit from other buses. So if you have like a master bus and then you have like a music one, and inside the music you have a background one, the background one is going to use all the parameters inherited from the music and the master, and you can override any parameters as well, and even add your own filters on top of it and things like this. And all this can be changed on the fly at runtime as well. That's a lot of talking. I'm going to drink a bit.
Is it possible to add an FX to this, like for this echo, the delay thing?
That would be great. Right now, it's not possible because the effects are applied on object. But if you look at the Trello, I have a card there where I want to dissociate the effects from the objects and being able to apply them to anything, basically. So you would be able to apply them to a clock or to parameters on the filters or things like this. But unfortunately, as of today, it's not done yet. The effects are only applied on objects. And another thing I want to do with effects, right now the curves are kind of baked in. We have like a set of curves that you can modify in the parameters. You can change their phase, you can change their amplitude, you can change their cycles. But I want to be able to like define free form curves, and also have like some other curves that are supported by Orx, like splines and Bezier. Right now you cannot use them in FXs. There's also another Trello card for this, which is to make a freeform curve and other type of curves into effects as well. But as of today, it's not available, unfortunately. You would have to write code to do that. So basically, you can have an object that runs your effects, and then you can poke the object to retrieve the value of the effects and then set it on your filter, but you would have to write that code to do it yourself. There is no bridge inside Orx to do it for you at the moment.
Okay, cool.
So yeah, so I have been talking a lot. It's been 1 hour. So if you have any other questions or like anything, I'm happy to answer them. Otherwise, I will thank you all for being here, and I will wish you all a great day/evening, depending on your geographical location. Well, I take that as we're good for now. So thank you all, and I'll see you in the next live event. Maybe I don't know yet. Maybe like in a month or something like this. Oh,
Someone's
sorry.
typing a question, maybe.
Oh,
Sorry.
Sure. No worries. Thank you.
Oh, never mind. It was a thank you.
Ah, perfect.
Yep, thank you so much. It was great.
Thank you all, and have a good day. Bye.
Bye.
Bye all.